Let's continue our discussion. Here is another example. Consider curves. We have y is equal to x squared plus 5x plus 6 and y is equal to 2x squared plus 2x minus 4. Solve for x when the two functions are equal. We'll try that. We have x squared plus 5x plus 6 is equal to 2x squared plus 2x minus 4. If we subtract both sides of the equation by negative x squared, sorry, not negative, just by x squared. And then if we subtract both sides of the equation by 5x, if we subtract both sides of the equation by 6, then the left hand side will be 0 is equal to, we have x squared minus the 3x minus 10. If we can factor here, the factoring is the best right now. It's the easiest because we have negative 5 and positive 2. And we will get negative 3. Then we have x minus 5 multiplied by, in a parenthesis, and then x plus 2 parenthesis is equal to 0. Then we have x minus 5 is equal to 0. Then our first x is equal to 5. X plus 2 is equal to 0. Then our second x is negative 2. We're going to find y also. We're going to find the coordinates. Just solve for x. Okay, but we're going to solve the y also. So we have y is equal to, we have, if I'm going to use this function, then we have 25 plus 5 times 5 also. I will write it properly. It's better. 5 squared plus 5 times 5 plus 6. Then we have 56. So our first coordinate will be 5 and 56. And the second coordinate, y is equal to negative 2 squared plus 5 times negative 2 plus 6. Then we have 4 minus 10 plus 6. That's equal to 0. We have negative 2 and 0. Okay. The B question we can answer later, but I want you to show the graph of these equations. We have x squared plus 5x plus 6. And then we have 2x squared plus 2x minus 4. And if we draw that line, I don't see that. So if I'm going to zoom out to make it right, there you go. Better. Okay. And if you push F5, then we have the intersection F5 once again. And we have negative 2 and 0. And the other one is 5 and 56. Then we did right. The second question, the B question, is solve for x, where x is x squared plus 5x plus 6 is greater than 2x squared plus 2x minus 4. That was the question. So if I'm going to draw it again. So the first, this equation is our x squared plus 5x plus 6, this one. So it should be greater. So then we're talking about this area. We're talking about this area. And we're talking about the x now is, for B, the answer will be when x is greater than -2 but less than 5. Okay, so our x, it's an interval. It's the area. I forgot to show. It's the area between -2 and 5. That one. Okay. Let's try this example. Y is equal to 2x plus k is a tangent. That means our discriminant b is squared minus 4ac is equal to 0. Remember that. So when we have a tangent, we only have one point of intersection. So if we have 2x squared minus 3x plus 4 is equal to 2x plus k. If we subtract both sides of the equation by 2x and by k, minus 2x there, minus k, then we have 2x squared minus 5x plus 4 minus k is equal to 0. So our a now is 2. Our b is equal to -5. Our c is equal to 4 minus k. Using our determinants now, and we have our determinant is b squared minus 4ac. It should be equal to 0. That's the definition of determinant when it only have one point of intersection. Then we have -5 squared minus 4 times a is 2 minus c is, multiplied by c is 4 minus k is equal to 0. Then we have 25 minus 8 times 4 minus k is equal to 0. If we subtract both sides of the equation by 25, and we have -8, 9. If we multiply -8 by 4, then we have -32. And -8 by k, negative k is positive 8k. Is equal to -25. If we add both sides of the equation by 32, then 8k is equal to what will be 7. And then if we divide both sides of the equation by 8, then our k will be 7, 8. So our function is y is equal to 2x plus 7, 8. Or y is equal to 16x plus 7.